So we just defined the equation of the plane in the form ax plus by plus cz is equal to the d, right? And in order to build this equation, we need to know the normal vector to the plane and 1 point, right? The coordinates of 1 point on the plane. So if you're given the normal vector and 1 point was the coordinates x1, y1, and z1, we can build up this equation. Ax plus by plus cz is equal to the d. From another point, if you're given the equation of the plane, is it possible to build the normal vector and find a point on the plane? Yes? So if you're given the equation of the plane in this form, then the normal vector to this plane is going to have the components a, b, and c, right? It is going to be the coefficient before x, y, and z. Then in order to find one of the points on the plane, we can just choose this by ourselves, right? For example, let's say we're given an equation of the plane in the form tx plus 3y plus 5z is equal to the 3, okay? This is just an example of the equation of the plane, okay? And for this equation, I would like to build the normal vector to this plane and find a point on this plane. So what is going to be the normal vector to this plane? 2, 3, and 5, right? And how to find a point on this plane? So there are infinitely many points, right? And we can choose them by ourselves, right? So we've got one equation of the plane and 3 unknowns there. X, y, and z are the unknowns. And I can build infinitely many points by picking 2 of the variables as I wish, right? For example, we can choose x to be equal to the 0, y to be equal to the 0, and find a z from this equation, right? This is going to be 5z is equal to the 3, right? Because this is going to be 0, 0. And from here, we can find a z is equal to the 3 over 5, right? So one of the points on this plane is going to have the coordinates 0, 0, 3 over 5. Can you give me another point on this plane? Just choose any values for the x and y and find a z from the equation, right? This is going to be, for example, let's choose x to be equal to the 1, y is equal to the 1. Then we can find out if you substitute 1 and 1 to the x and y to the equation, it's going to be t plus 3 plus 5z is equal to the 3. And from here, we can find a z is equal to minus 2 over 5, right? Another point on the plane is going to have the coordinates 1, 1, and minus 2 over 5, okay? So do you understand how it works, the mechanism, right? If we're given a normal vector and a point, we can build the equation of the plane. And if we are given the equation of the plane, we can find a normal vector and a point on this plane, okay? So now let's say we're given a plane. What's the equation, okay? So if the equation of the plane is given, it means that we can easily find a normal vector to this plane, and we can find any point on this plane, right? And now we're given some point which is outside the plane, and I would like to find a distance between the plane and the point, okay? In order to do this, I would like to choose one of the points. So let me choose one point here, P0, P1, okay? And let me do a vector to here. Okay, so let's denote this vector as a u. So we can easily get this vector, right? By subtracting the p1 from the p0, we can find this vector u, right? So the norm of this vector is not the distance between the plane and the point, right? Do you understand this? So because you choose this point, any point, right? Do you understand that this is not a distance between the point and the plane, right? So because if I would like to build a distance between the plane and the point, I need to make the perpendicular from the point to the plane, right? Do you understand this? So this defining the distance between the plane and the point in this way doesn't work because you can so we choose this point by ourselves as we wish, right? You could just choose the point here or there, it doesn't matter, right? And every time you would get the different vectors with the different lengths, right? It doesn't give you the distance between the plane and the point. In order to find the distance between the point and the plane, first of all, we need to make the perpendicular from the plane to the point, from the point to the plane, right? So let's make a perpendicular, right? And this is going to be distance, actually. This is the distance. And the other thing which I need to do is I need to find the length of this, okay? So this is perpendicular, right? Okay. You understand this? Good. So the distance is equal to this thing. So now, let's say we're given an angle here, alpha. Okay? If you're given this vector u, so u vector is given, right? Because if you're given a point, you can find any point on the plane, right? And by subtracting the starting point from the ending point, you can build a vector, right? So now you're given this vector. Now what I would like to do is I would like to find this part. Using the sine and cosine for this right triangle equation, what kind of equation we can build here? So adjacent side, right? The cosine u, right, and the norm multiplied to the cosine of alpha is equal to the distance. Right? Okay. And how to find this cosine of alpha? Huh? Actually, this vector, this green vector, is parallel to the normal vector, right? We can put the normal vector. Do you remember about the normal vector? So this is our normal vector. And this green vector is parallel to the normal vector. So basically, you can place the normal vector to any place, right? So the angle between the green vector and the blue vector is actually equal to the angle between the blue vector and the normal vector, right? So the cosine of alpha is the angle between the green vector and the blue vector, and at the same time, this is the angle between the normal vector and the blue vector, right? Okay, so we can find a cosine of alpha using the equation. So u dot n, right? Because this is going to be the angle between the vector u and the n, right? Divided to what? The norm of the u divided to the norm of the n, right? So now we can find the distance between the point by substituting the cosine of alpha to there. So the distance is going to be equal to u dot n divided to the u norm multiplied to the n norm, right? This was the cosine of alpha. And what is left here? So u norm. So u norm and u norm can be canceled because this is the constant, right? And what is left is u dot n divided to the norm of the n. Okay? So this is how we need to find the distances. Okay? So there is another general formula. So this is how we need to find the distances, but this formula is like a little bit unclear for us, right? So let's talk about more specific formula by substituting the components of the n and u. Okay? So if you're given the point P0 with the coordinates x0, y0, and z0 outside the plane, right? And we can find any point P1 with the coordinates x1, y1, and z1 inside the plane, right? Then we can find this vector u by subtracting P0 from the P1 or vice versa, right? It doesn't matter. So we can find this by subtracting the P0 from P1. It's going to be equal to the x1 minus x0, y1 minus y0, z1 minus z0, right? Now let us just substitute this. So our u vector has the three components, x1 minus x0, y1 minus y0, z minus z0, multiplied as a dot product to the a, b, and c, right? Divided to the square root of a squared plus b squared plus c squared, right? Because the norm of the vector is the square of the components, their sum, and taking the square root, right? Okay, if you open up the brackets and simplify the terms, you're going to have the following term. It's going to be ax1 plus bxy1, by1 plus cz1 minus ax0 plus by0 plus cz0, right? Divided to the a squared plus b squared plus c squared. Okay, this is the formula of the distance. Actually, we did a mistake here. So we need to write this down as okay. So the reason why I wrote this down in a different form is that so if you're given the equation of the plane, so do you remember how we defined the equation of the plane? It was ax plus by plus cz is equal to the d, right? And do you remember how we defined this d? D was the components of the point on the plane multiplied to the normal vector is the dot product, right? It was actually equal to the ax0 or ax1 plus by1 plus cz1, right? Where x1, y1, and z1 are the components of the point on the plane, right? This is d. So actually this term is here, is the d, okay? So the distance formula is equal to ax0 plus by0 plus cz0 minus the d divided to a squared plus b squared plus c squared. Okay, so let's do an example. So let's say we're given the two planes. So let's say we're given two planes, and I would like the distance between them. Okay? So first of all, tell me, what do you understand by when we say the distance between the two planes? Because the planes are going from, like, they're going infinitely to the infinite, right? They don't have the ending points. They don't have the borders. The plane is go from the infinity, right? What does it mean, the distance between the two points? The minimum distance between them, right? Distance between the point is the minimum the distance, right? So it means that if the two planes are intersecting, the distance between the planes is equal to the zero, right? Do you understand this? So this is not about finding the distance between the point and the plane. If you're given a point and if you're given a plane, we can easily find a distance using this formula. But if you're given the two planes, the distance between the two planes is meaning like the minimum distance between the 2 points on the planes, right? So if the two planes are intersecting, it means that the distance between the 2 planes is equal to the zero, right? So when I ask you to find the distance between the two planes, first thing which you need to find is whether they intersect or not, right? So there is one case when they don't intersect. So in which case the planes are not intersect, if they're parallel, right? Right? Do you remember what was the condition for the parallelity of the two vectors? So if you're given one vector u, the vector v is called the parallel, right? Because when we talk about the position vectors, two parallel vectors are going to be on the top of the others, right? So v vector and u vector are parallel, means that you can obtain a u vector by multiplying this to some constant, right? For example, to the 2. You understand this? if it is possible to obtain the second vector by multiplying the first vector to some constant, it means that these two vectors are parallel. Okay? So now, could you please tell me what is the normal vector of the first plane? Ten, 2, minus 2. What is the normal vector of the second plane? 5, 1, minus 1, right? So if the normal vector, so are they parallel, by the way? They are parallel, right? Because you can obtain the n1 by multiplying n2 to the 2, right? So indeed, if you multiply all the components, 5, 1, and minus 1 to the 2, you will get 10, 2, and minus 2, right? So by scaling the n2, you can obtain the n1. It means that they are parallel, right? So now you're given one plane. Was the normal vector n1. And now you need to build another plane so that the normal vector of the second plane is going to be parallel to the n1. It means that the second plane is parallel to the first one, right? So basically, let us build the second plane. This is the second plane, and this is the normal vector of the second plane. If the normal vectors of the planes are parallel, it means that the planes are parallel, right? Now it makes sense to find a distance between the two planes, right? Because if the planes are intersecting, there is no sense to find the distance between them because the distance is going to be equal to the 0. So please note that if you feel that the normal vectors of the two planes are not parallel, it means that the planes are not parallel, and the distance is equal to the 0 immediately. You don't need to find this even. Okay? So now, we're given one plane and the second plane, and they are parallel. Now I would like to find the distance between them. So do you remember previously we said, okay, so if I'm given one point here, I can find the distance from this point until this plane, right, this distance, using the formula. So the distance formula, so if this point has the coordinates x0, y0, and z0, this is going to be equal to the vector, right, from the first plane to the second plane, u. Dot product is the normal vector of the second plane, right, n2, divided to the norm of the second plane, n2. Okay? Now what I need to do is, if I'm given the equation of the first plane and the second plane, I'm given the normal vectors, I need to find the points. Okay? So actually, I need to find one point on the first plane and one point on the second plane. So how to find the 2 points on the first plane or on the second plane? So tell me one point on the first plane. So the first plane's equation is 10x plus ty minus tz is equal to the 5. Tell me one point. So in order to find a point on the first plane, just choose any values for the x and y and find a z from this equation. Okay? So let's put x to be equal to the 0. Y is equal to the 0. If you substitute 0 and 0, it's going to be minus 2z is equal to the 5, right? So from here, we can obtain the point, the coordinates of the point on the first plane. This is going to be 0, 0, and minus 5 over 2, right? Now we need another vector, another point on the second plane, because in order to build the vector u, right? Vector u is obtained by subtracting the coordinates of the first point from the second point, right? The point from the second plane from the point on the first plane, right? So if the equation of the plane is given as 5x plus y minus z is equal to the 1, how to find the point on the second plane? So basically, I would like to find this point P1, let's say, in order to build this u vector. Okay? So the P1, so again, I need to choose x to be equal to the 0, y is equal to the 0, z is equal to minus 1, right? So that is why the coordinates of the P1 is 0, 0, and minus 1, right? So the u1 vector is when I subtract the starting point from the ending point, right? P0 minus P1. This is going to be 0, 0, minus 5 over 2, right? Minus 0, 0, minus 1. Do you understand this? Okay, this is going to be 0, 0, and minus 3 over 2, right? Minus 3 over 2. This is going to be our vector u, okay? Now we just need to put everything to the formula and calculate this, okay? So this is going to be 0, 0, minus 3 over 2 dot to the empty. Do you remember what was the normal vector of the second plane? It was 5, 1, and minus 1, right? So this is 5, 1, and minus 1. And the norm of this vector, 5, 1, and minus 1, is going to be 25 plus 1 plus 1, right? Square root of 27. If you multiply this is going to be simply 3 over 2, right? Because 0 multiplied to the 5 and 1 multiplied to the 0 are equal to the 0. The only non-zero entry is when you multiply the third component, it's going to be minus 3 over 2 multiplied to the minus 1, which is 3 over 2, divided to the square root of 27, right? You can write this as a 3 divided to the 2 square root of 27. Okay? This is how you need to find the distance between the two planes. Okay? Do you understand this? Okay, so you might ask me why we're choosing x is equal to the 0, y is equal to the 0 here in order to find the points. Is it possible to find the distance between the two planes by choosing other numbers? And is it going to be the same? Let's check it. So if I would choose here x to be equal to the 0, y to be equal to the 0 differently, if I would choose them, for example, 1 and 1, or minus 1 and 1. So is the distance between these two planes would be the same? So let's do this. So in order to do this, so let's start from the equation of the planes again, okay? So the equation of the first plane is 10x plus 2y minus 2z is equal to the 5, right? Yes. So I need to choose the values for the x and y differently from 0 and 0, just in order to check whether this idea is true, right? So tell me any values for the x and y. I mean, we need to choose some easier ones, right? So let's choose x to be equal to minus 1, y to be equal to 0, or 1 if you want. 1. This is going to be, if you substitute them to the equation, what kind of equation you have? Minus 10 plus 2 minus 2z is equal to the 5, right? So this is minus 8. If minus 8 goes to the right-hand side, it's going to be, well, let's choose this node. Okay, minus 8 goes to the right, it's going to be plus 13, right? And z is going to be equal to minus 13 over 2. Do you understand this? So the point, one of the points on the first plane is going to be equal to minus 1, 1, and minus 13 over 2. Okay? Now, we're given the equation of the plane. The second plane is 5x plus y minus z is equal to the 1. We need to choose one of the points on the second plane. How to do this? Again, we need to choose the points as you wish. Okay? For example, let's choose x to be equal to the 0, right? So y to be equal to, for example, 1. Then what I need to choose for the z so that this equation is going to work? 0, right? So if you substitute 0, 1, and 0 to here, right? Substitute x to be equal to the 0, y to be equal to the 1, and z to be equal to the 0, right? And please note that z is found from this equation. We choose the two values, x and y, by ourselves, as we wished. And we found a z from this equation, right? When you substitute x to be equal to the 0 here, it's going to be 1 minus z is equal to the 1. It means z is equal to the 0, right? Okay. So this is going to be our P1 point, right? P1 is going to have the coordinates 0, 1, and 0. Now we need to find the vector u. Do you remember how we did this? By subtracting the starting point from the ending point, right? So P0 minus P1, right? Because starting point is on the first plane, on the second plane, sorry. So look at the image, right? So P1 is on the second plane, and P0 is on the first plane. We need to subtract P1 from the P0, right? Okay, so this is going to be minus 1, 1, minus 13 over 2, minus 0, 1, 0. This is going to be equal to minus 1, 0, minus 13 over 2, right? Now, in order to find the distance between the t-planes, what I need to do is u vector multiplied to the nt, right, divided to the norm of the nt. Right? So what was the nt? It is the normal vector to this plane. It has the components 5, 1, and minus 1. Right? So let's substitute this. This is going to be minus 1, 0, minus 13 over t. Dot product is the 5, 1, and minus 1. Divided to the norm of the second vector, or nt. This is going to be square root of 25 plus 1 plus 1. Right? So let us multiply this vector to this one. What you get? Minus 5 plus 13 over t. Right? Do you remember 13 over t is minus 6 plus 6 over 6.5, right? Okay, this is 6.5. Divided to the square root of 27. So minus 5 plus 6.5 is 1.5, right? Or 3 over t divided to the 27. This is going to be 3 divided to the t square root of 27. Okay? This is the same answer. So it doesn't matter which point you choose. And the only thing which you need to understand, how to choose the points on the planes, right? In order to choose the point on the line, you just choose one of the coordinates of the point as you wish and substitute this to the equation, right? For example, if your line is given with the equation y is equal to the tx plus 1, if you would like to find one of the points, just substitute x to be equal to the 0 to 1 as any number, okay? Because you need one of the points, any point. If you need one point on the plane, then choose x and y as you wish and substitute them to the equation of the plane, and you can find a z. And you can have the 3 components of 1 point.